Now, transformations are basically changes that are being made to a parent function. A parent function is what I would like to say the most simplest form of a particular equation, meaning there's nothing being added to it, multiplied to it. It's the purest form of an equation. So 3 functions we should be very familiar with are linear, quadratic, and cubic. Okay? Their parent functions are the equations below. Y equals x, right? That's the minimum qualification for something to be linear. So now, whatever line that you're looking at will be some alteration on this parent function. So whether you make the slope bigger and the line becomes steeper, whether you move the graph down or up to change the y-intercept, right? All of those things are going to be changes we make to parent functions. Okay, quadratic functions, hopefully you remember, give the shape of a parabola. Okay, and the most basic thing you need to be considered a quadratic function is that x squared. So that is your parent function. Again, this can flip, this can shift. So we're going to talk about how that happens. Cubic functions all have this general shape, right? It kind of goes up, has a little squiggle in the middle, and then continues going up. Sometimes when you add a lot of things to it, you'll get some nice big bumps, but in the end, they generally take the same shape, and it's very similar to this x cubed graph. Now, the ones you may not be as familiar with, well, maybe not absolute value, should know the absolute value parent function. Okay, that's y equals absolute value of x. It's a V shape. And you should be aware with the square root graph, okay, square root function, which basically looks like half of a parabola laying on its side. So it should not be so surprising to you that when we get to the cube root function, it's going to be the cubic function on its side. Okay, so notice if I took this graph up here and I turn it on its side, that's how I get this cube root function, okay? So we should be able to recognize these, including this exponential function, but I'll talk a little bit more specifically about that one. But we should be able to identify these general shapes by name, okay? So these are the ones that you want to make sure you have committed to your memory. You should be able to identify it from an equation. You should be able to identify it from a picture, etc. Now, the last one you need to know is exponential. And the reason I have exponential here separate is because I have a parent function of an exponential where we have a base 2. But the key feature of an exponential is that we have a numerical value as the base and x as our exponent. So another parent function could be 3 to the x. Another parent function could be 1/2 to the x, right? So the exponential function is special in that it can change for different bases, but they will all still have the same general shape. And if you remember, it also has an asymptote, which is exciting. Okay, so make sure you're able to recognize those parent functions. Now, the last thing we need to talk about are the different transformations. All right, what kind of transformations are you responsible for knowing? Well, there are reflections, right? Reflections in the different axes. There are vertical and horizontal shifts. So if it's on the outside and you're adding or subtracting, that is a vertical shift. If it's adding or subtracting on the inside, that's a horizontal shift. And if we are multiplying either on the inside or the outside, that's going to be called a dilation. On the outside, it's vertical. On the inside, it's horizontal. Now, what do we mean by inside or outside? Well, remember those parent functions we just talked about. Inside the parent functions means it's within, in this case for absolute value, the walls of the absolute value function. If it's inside for a square root function, it's going to be inside the square root house, inside the cube root house, inside the second power, inside the third power. Okay, so that's what I mean by the word inside. Whereas outside means that it is not being affected by any of those symbols that represent our parent functions. Okay, when we are adding or subtracting, right, for vertical shifts, up means plus means up, minus means down, straightforward. But when it's horizontal, right, on the inside, it's kind of going to be the opposite of what you think. If I see a plus, I'm going to go in the opposite direction of the positive numbers. If I see a negative, I'm going to go in the opposite of the negative numbers. So that's something you want to keep in mind. With reflections, again, inside versus outside. When it is on the outside of the function, aka the function is just being multiplied by a -1, that's going to be a reflection in our x-axis. Okay, whereas if it's on the inside of the function, inside the square power, inside the square root, that's going to be a reflection in our y-axis, meaning every point that flips to the other side of the graph. Okay, and then vertical stretch or shrink, basically what you want to remember, if it's on the outside, the bigger the number, the more it is stretched out. The smaller the number, the less stretched, the more compressed it is. And it will be the opposite for our horizontal shifts. So let's take a look at how this works. So you can be given any of those parent functions and be asked to identify the shifts. Okay, so what's happening here? Well, here we have the function y equals absolute value of x minus 3 minus 3. First, we need to recognize what is my parent function. Okay, so anytime I look at this, I look for the more general operation. So in this case, it's absolute value. So my parent function is y equals absolute value of x, which is what that first graph shows. So how do we shift or change this graph to represent those changes? Well, first we have to identify. If it is negative on the inside, that means we are going to our right 3 units. If it is negative on the outside, we are going down 3 units. So basically, when we work with parabolas, when we work with absolute value, we're going to start with our vertex, and we are going to shift it to the right 1, 2, 3 units, and 1, 2, 3 units down. Okay, now this happens to be a delta math graph, so it will shift all the rest of the points for you if you need it. And this down here, the non-dashed one, is the translated function. So let's look at one more. Okay, what situation do we have here? Well, we have an inside positive 3, right? So an inside positive 3 means we're going to the left 3 units. Here we have a outside positive 1, which means we are going up 1 unit. So the vertex of this parabola, right, because this has the parent function x squared, will have the vertex left 3 units, up 1. So this vertex will go to here. So everything would follow. Now, obviously, my graph is not going to be perfect because I'm going to do it quickly. But there's one other thing happening here. We have a negative on the outside. That negative on the outside, if you remember, is a reflection in the x-axis, which means all of these points are now going to flip to the opposite side of my vertex. So what was once facing up will now be facing down. So if we take a look, now obviously my graph is not perfect because I didn't have all the points moving piece by piece, but you see we have a very similar graph